Clearly not prepared for a stream today. There we go. I was actually humming along doing some other projects, and then I noticed the time. I wasn't totally prepared to hop on a stream. So I'm a little caught off guard, as it were, and I don't have an exact thing in mind, which is not a problem really, but it does mean I have to think about what I want to kind of do. And I think where I ended up yesterday was kind of working on finding some point data about paths that, like straight line paths that I drew on my iPad and then extracted path data from and blah blah blah. I think it would be good to kind of keep going along that train of thought and kind of hacking on different algorithms that I can use to kind of extract some useful data. So that's, I think, what I'm going to do. I do want to just show off a dumb little side project that I am still working on. I brought this up briefly before, but there's a YouTube channel called Drawfee that I think is fantastic. And I have a little program that can extract the screenshots, basically. So what I'm going to do here, copy the current time here, and if I go to this REPL, which is still set up, I haven't gotten rid of it yet or anything. If I run this, with that URL, and just give it a moment. Ooh. Oh, it's Drawfee demo. Of course. And I go over to this site here and refresh this. That particular image is extracted, and I put a silly little SVG animation on it. But it extracts the line work from this. It removes the all the other elements of it. I want to be very clear, this is not, like, the artwork is not mine, just the program is, right? So this Drawfee channel is exactly what you should be looking for if you're interested in this. They're like a comedy kind of art channel. I think they're quite awesome. But it works. It's probably not perfect, but it works, I think, reasonably well. I don't know. I haven't tried this, so let me try this this one here for a minute. The idea is that you could run this over. So I have no idea if this will look correct. It might chop the image. Oh, that actually worked better than I thought. As you can see, though, here, one of the back feet, it did lose some detail here. So there's a bit of a heuristic approach to the manipulation of the SVG to remove elements that are not part of the line work, but those kind of need tweaking. The problem is there's a lot of different potential scenarios in which this can arise, so it's not going to be perfect. But this isn't an entirely frivolous project, fortunately, because the backbone of this idea runs a thing that extracts from PNG into SVG elements, and then at that point I can manipulate it into a set of points and just run different algorithms on the points. That backbone is useful for all kinds of things beyond just taking goofy images off of someone's channel. In particular, it's related to what I've been working on already, which is stuff kind of like, oops. This, which is the green line here is one I drew myself, and these red dots are my first attempt at guessing the idealized version of the line through here. So that's kind of that's a real world use for some of the backbone functions in this silly little side project of mine. And just kind of a fun little fan thing because I really like this channel. So yeah, I'm happy that it was working because I didn't expect it to go that smoothly necessarily. So let me just make sure that the chat works on my phone as well. There's always a delay between the phone chat and the one on my computer here, so I want to try make sure things are that I am up to date on things. Okay, let's click here, pop this out here. All right. Anyone tuned in now? Welcome, by the way. Hope things are going well today. I'm feeling pretty good, feeling pretty casual. That's the kind of mood I like to be in, you know? Just kind of chilling with things. Yeah, so I've just intermingled all kinds of hacking and stuff like that into this main thing here. So my code is very disorganized at the moment. I'm going to leave it that way for today, and I'll spend this evening and tomorrow, since I won't be streaming at that time, I will probably be cleaning up the code, moving the parts of the code base that are actually useful into the SVG library, and cleaning up this side project thing to be well documented and actually finish up some finalized output, because this is fun but kind of useless, right? So there's probably what I want to do is, you know, put a little website up or something that like you can hover over the images and click through to that YouTube video or something like that, where the drawing starts. I don't know. Oh, hey Mike, how did everything go yesterday? Things went pretty well. Didn't get back till I was signing off. Oh, that's okay. I'm showcasing a dumb little side project that I was working on. I mentioned this a little bit before, but this is an image extraction thing that actually works from YouTube videos and stuff. I can show it here. I've got a URL here, and this is a tangent. I'll explain how things went in just a moment. If I refresh this image is extracted from a URL at a specific timestamp in a certain YouTube video. So that's actually working, and this is SVG path data. The reason that is relevant is, well, it's not totally, but that same backbone of path extraction stuff is what I'm using for this. And since I was just working on, so this green line here is the line I drew on my iPad, and these red dots here are my current best work at finding the idealized endpoints of this. So as you can see, it's offset a little bit. It looks like the offset is approximately equal, so I'm kind of close, but not totally there yet. So things are going okay. Now I can hack on these algorithms a little bit further. So today I don't have any strong plans. I just am gonna kind of keep hacking away a little bit. But yeah, I'm doing well, and this is a pretty good result. as far as I'm concerned. It's not perfect, but it's okay. And you can see a little bit there. There's a pink line drawn over this. So given some sketch that's intended to be a straight line, in the perfect world, you can represent that straight line sketch as just a path with 2 points. Its start point and its end point. And then you can apply, you could also kind of find the average thickness of that line and apply the stroke thickness to the idealized line. And so as a first step towards figuring that kind of algorithm out, that I have a result that is 2 points kind of close. I'm reasonably happy with that so far. It's not bad. But there's all kinds of things I can do to improve. And my first guess as to why there's an offset here is related, I think, to the fact that the midpoint of this shape probably moves around a little bit as you rotate the shape, right? So the midpoint of any given shape, the simple midpoint, I'm just using, I'm just calculating, how do I describe this? So I don't know if this is true, but basically the midpoint of anything is just the average of all the points of that shape. So it could change around if it's kind of a lumpy sort of shape. I don't know if that makes total sense, but that's kind of the thought I have. So today I'm going to attempt to work on this. Just want to see that I'm distracting myself for a second. I'm just testing something. Okay, cool. Glad to hear it's all going smoothly thus far. Yeah, thanks, Mike. It's yeah, it's good. I have no strong plan for today, so not totally sure how things are going to go. I think I could come up with something useful to do, but I'm a little distracted today. I'll just say that up front. Hope that's okay. Sometimes it happens. It's just the way it's going to go. Right, so where I'm at is sketch to path stuff. Right here is kind of where I'm looking at being. Yeah, all good, man? Okay. Thanks. I do appreciate that. Some days are just like that. Some days are just like that. I think I have to readjust my schedule a little bit too. Not sure if I've ever mentioned it on a stream, but I have access to what I call the bunker gym. My brother and I built some gym equipment and put it into like a little back room of a shop that we're allowed to go into. And my mom and dad started working out with us in there. My brother and I, we work out, we lift weights and stuff like that. And so we started teaching them how to lift weights and all that sort of stuff. But I'm wondering if that, like, we have to go kind of later in the evening sometimes, and I'm just wondering if I should kind of shift my schedule around a little bit. because it might, you know, I might be a little more tired and a little more distracted because of all that. I don't know. I'm just kind of spitballing a little bit here. I'm not totally certain. Problem is, I don't want to. I love the working out, so I don't want to stop doing that kind of stuff, right? That's the thing with all of that. So I gotta just remind myself what I'm looking at here. Okay, if I run this, it should output this exact file. It should work. Okay, we're good. Perfect. So let's just start with something simple, right? Something very simple. I want to see if I'm on the right track with the offset being related to rotation and things like that. So I'm going to adjust my approach here a little bit. So this here, minimize bounding box height, is where I have the sort of algorithm for finding the minimization of the bounding box height by rotating through a range of 180 degrees. So what I can do instead is I think this is safe to do. I think. I'll find out. All I want to try to do is, instead of rotate it through 180 in the positive direction, I want to rotate it through in the negative direction, which should get me the minimum. It'll still get me the same minimum bounding box height, but the shape itself, instead of being rotated pointing this way, it'll be exactly mirrored. Not mirrored technically speaking, but flipped the other way. And so I kind of expect to see these points offset in the opposite sort of direction, because I think the angle will be the other way. I'm not sure if I'm making any sense, but let's just run this and see if there's any difference. Well, there is not. Okay, so it's possible that nothing important happened there. Let me check this. If I go range 0 to -10 with a step size of -0.5, what does that actually do for me? Okay, so it does work as I expect, so that's not bad. That's not bad at all. Not bad at all. Right, so well, now I have to think about this a little bit. One thing I could do okay, let me get some of this data in the REPL and go work on it from that perspective. So oh right, I have this little function here. iPad gets me a lists of points, which is useful. So using that, well, actually what I kind of want to do is this instead. Right, let's run that, just make sure error. Oh, I forgot the arrow. Okay, so that that gets me a forge shape directly, which is useful. Let me think about this a little bit. Checking my messages, sorry. Just, oops. Make sure things are working there. Okay. Right, so what am I trying to achieve here? I'm just trying to get some data in the REPL that I can kind of inspect things as they go. So here, let me def. I never know what to call silly names, so I'll just I always use ASDF as like, I know people use like foo a lot, but I like ASDF. Sounds cooler to me. It's just a garbage name that is useful for like doing REPL related stuff. I'm not sure what like professionals do. Exactly, when they want to name something, but the name itself is completely unimportant. Okay, what am I doing? Oh yes, I'm just defining this as iPad to forge. So I have the shape, like the map that is the forge model that just corresponds to the green shape here, that's all. Mike, we spend hours debating names and then ultimately rename it anyways. Man, naming things is genuinely tricky because you kind of want it, like, it's a challenge, I guess, because you want to kind of be able to do it quickly so that you can write the logic of your programs and stuff like that. But if you gloss over naming things too quickly, then you can end up making things that don't make any sense to someone else reading it, so legibility of your code goes down. But if you spend too long trying to come up with names, then like you're not actually writing a function, you're just trying to come up with a name that encompasses everything. Oh, it drives me nuts. So it's a weakness of mine to come up with clever, or you don't want to come up with clever names, you want to come up with good names that convey the right amount of information. It's a challenge for me. But when it comes to this, ASDF works just fine for right now. And then I just overwrite it. I just use it again for other test data as I need. Maybe it's not the smartest thing, but it's how I start doing it now, and I haven't run into real problems, so. You're not wrong. Everyone in the dev world has looked at code and wondered, what the heck does that mean? Yeah. I guess, that's one of the reasons why doc strings and good documentation do become important, right? Is, where you can't be totally, where you cannot remove ambiguity in a function name, you can improve the situation by writing good doc strings and by writing good full documentation, presumably. But it is really nice to have intuitive names as much as possible, in my opinion. It's a whole tangled web. I kind of feel like probably over time I'll get kind of this intuitive grasp of this kind of stuff a little bit better, and be better off for it. As I start to move the libraries I'm working on into like legitimate releases and open sourcing things, that's really when I hope and expect to have to iron out a lot of naming inconsistencies, argument order consistency, and doc strings that really elucidate how you're actually intended to use things. It's a lot of work, so I kind of am not looking forward to it entirely. But at the same time, I do actually I do love writing documentation, because it signifies that you're intending other people to read and use things. So it's kind of fun, and I'll get there soon enough. There's kind of two schools of thought. One group that thinks code should be self-documenting, which with comments and documentation really for complex stuff. Another group that thinks every method should have full doc strings and end up with more comments than code. I think, like most things, reality demands a sort of hybrid, balanced approach between these sorts of two things. That's my guess. So one thing that I admittedly don't do completely well yet, and it's something I'm working on improving, is using Emacs and org mode to create what's supposed to be called a literate program. So I do this all the time. I write little notes to myself with code blocks here, right? So I have kind of a bunch of different spots where I can put notes and documentation, right? And as you can see, I don't write doc strings. That's a bad habit of mine, in my opinion. But I do write notes to myself here. But a note here makes more sense in either a generated document website or a blog post, right? But I think is still extremely valuable for explaining thought processes and how I arrived at a potential solution. Doc strings make sense to me for trying to make the arguments that you need make sense. And that's something I'm also not perfect at. Like in Clojure, what's a good example here? If I have to, so get in, for example, here, if I look at what the arguments are, it's M and KS. And that is rather opaque to someone who doesn't totally know what's going on. I happen to know that M is commonly used as map, to mean map, like a hash map, and then KS is keys, as in like, so get in some map with a nested structure, right? And then keys is, I think you can do this, A, B, yeah. But the arguments themselves are not always immediately obvious, right? So I feel as if a doc string would be a good place to kind of clear up the ambiguity or the confusion if there's someone who doesn't know some normal conventions and stuff like that. Or if your own library breaks convention or has its own convention, you know, it's important, I think, to use doc strings for that kind of thing. So you get kind of high-level thinking related things in what I intend anyway, just in the org file. So as prose effectively, which I can put into API docs, generated docs pages, or wikis, or whatever, blog posts, who knows. But then doc strings are useful for the user at the REPL when they're writing stuff out using functions and whatnot. And then comments are, in my mind, something where if someone's reading the code on, say, GitHub or something like that, good for the occasional headings minor notes of importance or hacks or something, but nothing that would make more sense in a blog post or wiki, basically. And that's kind of how I intend to be structuring the human readable side of my code base. But I do also at the same time like the idea of writing functions to be easy for a human to kind of reason about. Functions that end up being too clever are they kind of become a black box by accident, and I don't think that's very useful for anyone who ever has to use the code. So that's, in my idealized perfect world, that's exactly how I would do everything. But I'm almost certain there will be exceptions and stuff like that as time goes on. But that's kind of my idea. I think it's achievable, more or less, anyway. So let me see, just to finish off this thought, since I sidetracked myself, as usual. Clojure.repl/doc. If I do the doc for get in, what does that print out here? Yeah, so here, this is a really good example. If I did not understand as a new user what M and KS were supposed to be, I could read the doc string here, and it says returns the value in a nested associative structure where KS is a sequence of keys. Okay, there we go. Now I understand what that's about. Returns nil if the key is not present or not found, or the not found value, which is also another argument here, if supplied. Okay, so the only thing that is, to a total new user, that's still a little bit confusing would be what is M, right? It's implicitly stated in this thing here, returns the value in a nested associative structure, but you kind of still need to know what that means in order to understand that, oh, that's what M is. So, you know, but that at least explains what you get out of the function and what you're supposed to put in. And I think that makes sense. Anyway, that was a bit of a digression, but I'm okay with that. All right. What am I in the middle of doing here? What am I trying to do? Oh yes, that's right. So ASDF is a shape map from my Forge library. So now I can run minimize bounding box height on ASDF directly, and it should give me a map of some data. Yes. Okay. So this angle here is in fact different than if I do this. If I change the function and just spin in the positive direction, the angle is different. It's not surprising that it's just the difference is like the absolute value of these angles adds up to 180, which makes sense if you think about rotation and a minimization point. That makes complete sense. I also, just as another little thought here, you can theoretically increase the accuracy of an angle, like of the minimization by having a smaller step size. Of course, you slow down the whole algorithm. The more steps you have to run through, since this is just a naive approach, the slower the algorithm becomes. But for experiment and for hacks and experiments, it's theoretically okay. So that did move the points. It's maybe hard to see there, but it did. I promise you. I am going to be right back though. Get myself a little bit of coffee. It won't be long, but I'll be right back. Okay. I'm gonna try adjust this precision one more time just to see what kind of real difference that makes. I don't expect it to make a massive difference. Yeah, I didn't even see a change there. So I'm actually gonna go ahead and leave this step size as 1/2 degrees, and that should be, I think, pretty reasonable. Okay, so let me just run that again. Should keep things relatively quick, even though I'm just hacking, you know, it's better not to bog things down unnecessarily. And now, oh, I know what I'm gonna do. So I'm gonna make a little function that rotates this line through 180 degrees with a step size of 1/2 and just calculates the new midpoint at every rotation step. Then I should have a list of points and I can draw them on the screen and I can see the, you know, if they move at all, which I think they do, but I'm not totally sure if that's why I have this offset problem. That might still be something different. Okay. It's a pretty reasonable next step in my opinion. I think it could work nicely. Okay, so to do that, actually, all I really need to do is for range 0 to 180, step size of 0.5, that's fine, it's good enough. Take the shape, actually just report f/midpoint of, I'm getting a little ahead of myself here. Let's do let the shape be f/rotate about z 0, 0. Oh, I have to actually, this is horrible. This is not the right syntax at all. I don't know what my brain's on about here. That doesn't make any sense. Sometimes I just have like a complete and utter brain meltdown, apparently. Oops. Okay, so let's let the shape just be rotate around the z axis of the shape itself by 90 degrees. And since I'm just doing it in the REPL, I know the shape is ASDF, so this is not a function, I'm just running the code directly. That's the shape. And then here, all I need to report, basically, I just want to calculate the midpoint, which I can run on. Midpoint is actually just apply concat to, oh wait, no, I don't think I need to do concatenate. I just need to pull vertices from shape. And I think that'll actually work. Oop, not quite. Not quite. Okay. I might have my, yes, of course. Classic mistake. My order of arguments is wrong. Boom, there we go. Okay, so now, interesting. There's quite a, something's not totally right here. Oh yes, of course. In this case, the midpoint will actually sweep an arc 180 degrees more or less. So if I actually draw this, so let me give this a little name here. WASD. Really clever. Really clever. If I draw that as, let's do hot pink. It's a cooler color. This path polygon I'm going to temporarily do as this, and I think that should not cause an issue. I don't know where it is. It's disappeared entirely. Intriguing. Why would that be? Probably because it's just like being drawn somewhere else. Let me see. I don't know. I don't know what I'm talking about. Path. Oh, interesting. Maybe it's not as crazy as I thought here. Let me try bounding box area of WASD. Oh, what? That's huge. I don't understand. Bounding box points. Let's just do that. Yeah, okay, things are way out to lunch on this one. Yeah, that doesn't really make sense. So, well, okay, so what I think is going on, I don't know why it's not drawing correctly, but that I'll just ignore that. I was trying to, I won't worry about why it's not drawing correctly right now. I'm pretty sure the bounding box of this set of midpoints is all wrong because I'm rotating it globally, not locally. So am I thinking about this correctly? That's the thing I don't know. Let me see here. If I go over to this, I let base shape be the f/translate. First, let's do let's mx my nothing is f/midpoint of ASDF. What I'm doing here is finding the midpoint of the shape before I do any transformation to it. And I'm permanently transforming the midpoint yeah, this makes sense to me. Negative mx, negative my, and 0. Okay, so doing that should translate the thing to the origin point. So now any rotations applied to it are as if it's local. with the midpoint of it at 0, 0. So it should kind of more or less spin around its center point. I think that makes sense. But here now I'm gonna rotate about X ASDF, and then the midpoint is at the vertices of that shape, but I also want to, before I just pass that on, the actual answer is just going to be f/v plus mx my 0 plus the midpoint. So it's shifted back to the global center. Oh, wait a second. No, that should, maybe that'll work. Let's see here. I messed something up. That's totally fine. Let's go back here and have a little closer look that things are actually working here. This should work. Well, okay, I'll look into that. Okay, keyword cannot be cast to number. What did I miss here? Vertices of WASD is nil. I goofed it up. Well, let me go ahead and just, you know what, this is a little silly to be doing this just in the REPL here. Let me just copy it into here so I can kind of keep poking at it. Let's do this. Split that. Okay. Messy code, messy code. That's the way it is today. All right. So here I've got a problem. Does this work? It should work. Okay. So I'm already messing something up here. Oh, yes. I know what's going on. So I jumped the gun here. I forgot that midpoint works on a list of points, not on... I have to do this here. I have to pull the vertices out of this. And now that should work okay. Let's give that a shot now. So if I have a look at this... in fact... most of the points are exactly the same. So with a really quick, in fact this is the same, it's just got a floating point problem here. Same with this. Does that make sense? Or am I just being very silly and not properly thinking about what's actually happening here? Let me think for just a moment about that. So I translate this original shape to the calculated midpoint of that shape, or to 0, 0, so that its midpoint is centered around 0. Then that new shape, X ASDF in this little example here, I rotate one, like a half angle at a time, and the new midpoint should theoretically still be the average of all those points, and just because all of them rotated, it still makes sense that they're going to be at exactly the same midpoint, And then all I do at the very end, or for every step, I just add back the translation to move its midpoint back to its real midpoint. So this, roughly speaking, tells me that my guess as to why these points are offset, being about the midpoint kind of shuffling around, is not quite right. So that's useful in that it tells me that I was thinking about it a little incorrectly, but now it means I don't know exactly why I am miscalculating these endpoints, which is actually okay. Let me try another thing now, actually. If I do if I do if I just do this for a minute, I think that will give me the horizontal version of this. I think that makes sense. Okay, so let's change this back to eye points. Yes, okay. That's the horizontal version. But I also want to rotate the original green point by that same angle to see how close the endpoints are. See if the offset's there as well. I think it will be, actually. Okay, easiest way to do that. Where am I looking here? Oh yeah, points. Transformed points. Oh, these are basically unneeded in this case, but that's fine. Let me just hard code this rotation for a minute here. If I idealize endpoints 2D of the shape ASDF, it's the same shape. Oh, that's the wrong thing. I should have done minimize bounding box height. Here, the angle is 144.5. So here, I can actually paste that here, and that should draw the green line horizontal as well. There we go. So the offset does indeed show up here already. So that is interesting to put it simply. Okay, so we've got the let's go back to the data here. This midpoint. me just concat minimize, oh yeah, minimize bounding box height of points. No, it has to be the shape, which is, oh man, I'm kind of all over the place on this one. That's okay though. Apply f/polygon2 to points. I don't need the hash there because it's not the function there. So if I get the data from that shape, that should work. And then iPoints, I'm just gonna concat or sorry, conj, which takes the collection first. So conj onto the end of the vertices from the data, conj the midpoint from the data onto there. So now I'm drawing 3 points. Ooh, bad call. What did I do wrong here? Oh yeah, this is not what I need anymore. Okay, there we go. Right, so I broke this. That doesn't draw a line anymore, but that's okay for the time being. The points, the midpoint, something's not quite right here. Something's not right. Yeah, okay, so I wonder if this midpoint here is not correct. Okay, that draws a line now. That's good. All right, what's going on here? So the midpoint is not recalculated here. So if I recalculate the midpoint, let's try that. Let me try that. For every angle, I'm going to recalculate the midpoint, and that will become the new basis of the calculation for the point offsets. I don't know if that'll be more accurate. I thought that it wouldn't make a difference, but let's try it anyway. Why not? So using okay, oh wait a second, let me walk myself back just for a minute here. had to step out for a few. What did I miss? Not a ton, to be honest. I'm walking myself through the logic of this algorithm, trying to figure out why I have this little offset here. So this red dot is the current estimated endpoint of this line segment, and it appears to be offset on each end by a little bit here. So I'm just trying to walk myself through why that might be happening. Oops. And I'm in the middle of trying to figure out if it's related to midpoint calculation. So that's where I'm at. The reason this kind of matters is if I ever want to get to some crazy system that can kind of discern from a human sketch some nice straight lines for CAD data, I do want it to figure out endpoints reasonably consistently, right? So this matters, and just kind of slowly stepping through things, that's all. So what I'm going to try next is this minimize bounding box height is what I'm looking at the moment. It steps through 180-degree rotations at a half step size, and then just sorts that whole list by the minimum height of the bounding box around the thing. And it returns the midpoint that was calculated before any rotation. So I'm kind of wondering if there's something wrong with that assumption. So what I'm actually going to do is change up a little bit here, this X shape here. And I'm going to do that by just rewriting this a little bit. Oops. So what I'm going to do is actually transform X shape shape gets the pipe treatment. It's f/translate. I'm going to give this a shot. I'm not sure it'll work, but it's the only thing I can think of at the moment. my0. So what I'm doing here is translating the whole shape to the on the first angle there's zero rotation at all, so it's the original shape. And if I apply a translation, that's the negative of the midpoint X and negative of the midpoint Y, that has the effect of moving the whole shape to 0, 0, so to the origin with its original midpoint as the center. Then if you apply a rotation, it rotates about 0, 0, whereas if I don't do that translation, it rotates the shape about the global axis. So its local midpoint is changing kind of drastically, because it's you know, if I'm spinning, if my finger is the origin, if I rotate this coffee cup about the origin like this, it just spins about my finger. But if the coffee cup is in 3D space here, and I apply all rotations to objects about the 0, 0 point, the rotation now has the effect of the coffee cup moving like a big distance in 3D space. Whereas now, if I calculate the midpoint of the cup, translate that midpoint to 0, 0 by subtracting the magnitudes, right? Apply a rotation, it rotates about the origin, and then if I apply the translation back to the original midpoint, it has the equivalent effect of a local rotation, just like this. So that's what I'm trying to replicate here with these translation steps. Hey Biz, how's it going? Hope you're doing well today. Okay. I have no idea if that'll actually like solve this particular issue, but I think it might, so it's easily worth a shot. Okay, minimize bounding box height. Let's give that one a go. Zoom this out just a bit here and have a look. What's new today, Biz? Same old, same old? All right, let's see if this actually works or if it causes an error. No error, that's good. No change. Huh, okay. So that's not the particular issue. Oh, of course, I'm being silly here because tapping out from work for the day? Fair enough. You know, sometimes you got to take those breaks. Okay, so I goofed here. This shape, so I took the shape, I translated it to 0, 0, I rotated it, and then I translated it back. Oh no, never mind. I don't know what I'm talking about. This should have worked the way I thought, but it didn't. So, now what? Now what? Well, I could. Okay, let me try this next. Let's try this next idea a little bit. So, all I need to do is remove those translations. Okay. No, that's not totally right. I'm going to leave this translation. So that moves it to the origin, then I do a rotate. You're tired of application development? You mean at your work you're tired of app development? Biz, I forget. I know you're a fan of F#. Do you use F# at work? Or do you use F# for your own projects? I can't remember. Yeah, tired of app development at work, yeah. Yeah, man. I know how that feels. Well, kinda. You use F# for one of your clients. Okay, gotcha. So you're tired of app development. Are you tired of programming in general, or you also write it every day outside of work? Gotcha. Okay. So F# is something that's kind of what you actually really love to do if you're doing it outside of work, would be one of my guesses anyway. So you don't. It sounds like you don't want to quit programming per se, but you're just getting a little bored of the app work, which I would understand that. That makes sense. But hopefully you're doing okay otherwise. Yeah, F#'s your go-to language. Makes sense. I gotcha. What am I doing? Right, so I'm going to try something a little different here. Oh, let me, okay. I'll do the translate thing. The only difference I want to do here is calculate a new midpoint to be nmx, nmy, and I want to do that by calculating the f/midpoint of vertices of X shape, and instead of passing mx, my here, I'll pass nm, and I don't know if that'll make any difference, but I'm going to give that a shot. If this doesn't have a visible effect, I'm going to kind of step back again and maybe rethink this whole approach. Okay, no visible effect. That's fine. I have to figure out what to do next. You hate troubleshooting UX? Yeah. UX is tough. I kind of wonder sometimes if UX is tough because it's like the point at which every program gets like thrown into the wild where experts and non-experts alike happen to interface with things, and it can become this whole battle arena of people's opinions about what they think would make sense and all that kind of stuff. And then at the same time, UX can be finicky even if everyone agrees on something. So yeah, UX is sometimes, unfortunately, it's really important, right? Because it's the interface for a lot of people. That's the way of the world. Just don't get paid enough. Yeah. Yeah, you know. Wouldn't it be nice, eh? Wouldn't it be nice? Okay, I want to head back to the drawing board on this algorithm because I have lost the plot and I don't know what I'm doing anymore. I think that's a good reason to want to fix it up. Let's try this. Just make sure that the basics are still functioning okay. Oops, it's not rotated anymore, or this should be 0. And what have I done now? Yeah, that's... Oh, right here. This has to now be... Instead of this, I can just do... What's the name of this weird function? Idealize endpoints 2D. Lost it. Where is it? Yep. Code's getting messy today. That's fine for this, but tomorrow, big code cleanup I think is on the docket for my work. Should be okay. Right, so here, idealize the endpoints of the shape. Where is it? What am I talking about here? Is refactoring hard in Clojure? No, not particularly. I mean, refactoring is as hard or as easy as the individual's ability to write reasonable code, in my opinion. Maybe that's a bit of a cop-out answer. No, refactoring in Clojure isn't particularly difficult. The hard thing for me is going to be the fact that I'm not using the most automated workflow setup. So my own workflow that I kind of stumbled into as I was learning Clojure was really on the manual side of things, which I don't think is bad, but I haven't tipped over to good automated tooling. So it'll be hard for me, but is not hard for an expert, if that makes any sense. Can you rename a function with cascading updates on client calls? I can't with how I've got it set up. I'm pretty sure there's tooling for that kind of stuff though, although I don't know for sure. But I'm pretty sure that there is in fact, you rename a function and all of its call points get updated as well. So I'm pretty sure that exists. I just haven't set it up. So that's a me problem, not a Clojure problem. Okay. What am I doing? think this will work. Yeah. Right, so we're back at this problem, and I don't know why. So what I want to do instead is maybe come up with a different approach. And that approach will be what? I don't know yet. Let me think about this. Okay, if I'm given I'm just thinking about if I have a line segment and it's just represented, like it's actually a polygon of just a bunch of points. Is there something clever I can do with those exact points to find minimal subsets of those points that still represent the shape reasonably well? Like, could I just sort them all by like, could I cut them in half and then get a new midpoint and then just do that a few times for the lower half and upper half and subdivide some straight line thing into midpoints? And if I run that enough times, you get closer and closer and closer to the ends. Does that make any sense? I'm getting ahead of myself here. Let me all right, I'm going to try something that's theoretically way easier than all this stuff I've tried to do. What I'm going to do is just change this function. And all I'm going to do is take let points be vertices from the shape, and then what about drawing a line from the start and end point, then excluding all points that exceed a certain threshold I define as the distance from that best fit line as a start. It wouldn't cover traditionally non-straight lines, but it would give a starting point, right? It would. The thing I'm trying to come up with is a fast way to get the best possible start and end points, right? So what I mean by that is if I draw, let me go to this messy function here for a minute. If I take as an example, okay, example point. Let's make that first from the list of points. Okay. There we go. If I just do, instead of for point in example point, because I'm lazy, I'm just running the for loop over a single element. Oop, something went wrong. What did I do? Oops. Oh man, I'm falling to pieces here. Okay, so example point should work, right? I thought it would anyway. Okay, so it draws in that case, that's fine. Ugh. Oh, right, okay. First of points. Oh no, let's do first of apply concat points. It's just a structure problem. Okay, so I don't know where that point was drawn. Oh right, nothing was drawn there. That's silly of me. What am I trying to say? If I can actually get that point to draw on here. So it's not, so in this case, I pulled literally the first point off of the path list, and it's pretty clearly very close to an endpoint, right? But if I were to, is last a proper function? Yeah. So if I do first of reverse of this, it's the same, it's basically the same point. And the reason for that is because the list of points goes like this. It's, you know, point number 1 is here, point number 2 is here, point number 3 is here, up to point number 100 or something is, oh excuse me, is here, then 101 is here, here, here. So it goes around both sides of the line in a closed loop. So the first and last points are guaranteed to be at the same point. So I could only ever use that to get maybe this point here. It's also not, strictly speaking, guaranteed that the first point of the polygon will be at an endpoint. It could arbitrarily be in the middle of this line. So I need some different approach to grabbing this point and grabbing this point, and I'm trying to come up with that. Hope that makes sense. I don't think it's really actually that hard. I might be stuck in an overthinking kind of situation. But what I want to do is actually try this. So I want to take first from sort by first of points, and I also want to take first of reverse sort by first. Oh, let's be a little smarter about this. Points sort by first. So sort by first means it'll go from it'll rearrange the points to be from the lowest x value to the highest x value. This technically will ruin the polygon, but if I'm only considering the points for a brief analysis, the order of those theoretically doesn't matter all that much. That's the idea I'm going by. See if it makes sense. So since they're sorted, I want to pull the first from that points list, and then I also want to pull first from the reverse of the points list. Let's try that. Pardon me. So now the I points might be better. Let's see. Hey, wow, that worked quite a bit better for finding those. So now that I have a reasonably good start point and a reasonably good end point, if I actually just draw a straight line between those, which I thought would be okay. Oh yeah, that's right. I need to oops. Boy, this is so messy. Oopsies. Okay, let's get rid of this midpoint nonsense, and I'll just do this. Okay, I points is mat v drop z over the function idealize endpoints 2D of the shape Is this gonna work now? No. All right, I'm gonna step away from this just for a second. Okay. Hi, sorry if I mispronounced your name. Hi, Vakali. Apologies if I got your screen name wrong there. How are you doing? I hope you're doing well. Hope you are doing well. Alex? Okay, I'll do my best to remember that. And if you're cool with me calling you Alex, then I'll call you Alex. All right, let's see here. What's new in the world of Alex? How you doing today? Okay. I've just completely mangled my... This is such a hacky piece of work right now. I'm not happy with it. Not super happy with it. Oh, hey, Alex, thanks for the follow. I appreciate that. It's really nice. I'm curious if maybe I missed it, maybe I didn't. I have this little silly animation that should go when there's a follow, so I'm all over the place today. It might have happened and I might have missed it, but we'll see. Or maybe it comes like minutes later. I'm not sure. Either way, I appreciate the follow. It's really nice. Okay. What am I even trying to do here? Okay, idealize these endpoints for this shape. That gives me two 3D points here. If I map V drop Z over that, does that work properly? It gives me two 2D points, which is fine. So here, this is the part that I've got wrong, and the reason for that is because I'm not thinking clearly at the moment. So Alex, do you use Clojure at all yourself? By the way, so I'm asking questions directly. I always enjoy it when people talk in the chat, but it is totally okay if you don't feel like talking, you don't feel like answering questions. That is completely fine, so don't feel pressured. But if you're interested in chatting, I'm curious about what brings people here, what kind of stuff they're working on, that sort of thing. So feel free to share if you want. Ask questions, you know, talk about whatever. I'm cool with it. And if not, I'm cool with that too. Okay, here. Oh, it's not Polygon 2D, it's Polygon 2. There we go. There we go. Okay, so what I've done kind of works. I have a start point and an end point. The issue or unissue, maybe I should try to, let me see here. This hot pink, let's make it 15, maybe. And the, here, the fill, let's change the opacity of these circles just a little bit here. But now I've got something to work with, which I'm happy about. Okay, so the opacity, it's a floating point value, I think. So let's make it half. I think that'll work. Cool. Okay, so here, right, to get this endpoint, which is closer than what I had before, it's not too bad. I just have the minimum X value point. Pardon me. But since there's a thickness to the line drawing itself, it's actually a little bit wrong. I would prefer it to be up on this ridge slightly. And likewise here, this is a little too far to the right. So I wonder if there's a way that I could kind of get a little bit closer to accurate. And I have an idea with that. So here, what I could do is actually find the so if I idealize the endpoints, what I can actually do, how do I want to average the first 2 or 3 points? So that's close to what I was thinking. Since what I have here, so this is maybe a little confusing here. What's happening is sort by will sort a collection using the function that you provided here. So in the case of a list of points, right, I have a single point in my shape. They're 3D points, so 0, 0, 0 is a single point. But if I have a list of points, 0, 0, 0, oops, that's not what I meant to do. -10, 20, 2, -2, 3, 45, doesn't matter. If I sort this, sort by first, it will, for every element in this list, take the first element from the point and sort it by the value there. So -2 is lower than 0, which is lower than 10, right? So that's how it sorts. But you could sort by second, and then you get the sort of the points where the y value is the thing that sorts it. So what I think would make good sense, or might make good sense, is sort by the y values and the x values, and then get the midpoint, get the average of those 2 points on each end, and that might get you kind of closer to the middle. So it's similar to what you're suggesting there, the average of the first 2 or 3. But I'm sorting by x, then sorting by y. That gets me the points clustered there, and then the points clustered around the maxes, and then I can use those averages. So it's, maybe I'm just saying exactly what you've said. But I'm going to try that out. It could work. X points and y points here, sort by, whoopsie, sort by second vertices of the shape. Efficiency is not the name of the game for me today, I'll tell you that. You are articulating it way better than my one-line idea. Ah, okay, okay. So then maybe I'm just reiterating what you had tried to suggest earlier, in which case, sorry if that frustrated you at all, but I've arrived at an idea. Hopefully it yields some decent results. Okay, so I actually just need, I should be able to do this. f/midpoint of first of x points and first of y points. Is that right? I think it's right. And here, oops, I'll just do this. f/midpoint of first of reverse points reverse x points, I should x points reverse y points. Okay, that should maybe get me a result. Let's give it a shot here, right in the REPL. Ooh, it gives me points, but I want them to just be in float values up front so that it... Does that matter? I wonder maybe if... It might not matter. It might coerce it later on and be okay. Let's give it a try. Ooh. Okay, so the line that I drew went away for some reason, which I'll figure out in a moment, but that looks better in my opinion, and that also looks better in my opinion. That looks pretty good. I'm quite happy with that for now. Let's go revisit this for a minute just to solve that little problem there. I'm gonna just coerce these to floats. It's ugly, but for now it'll work. This is a major flaw in how I've designed some of these kind of property calculating functions where those are some mighty fine looking points. Hey, Alex, I'm beginner. So there's I have a Nightbot mod there. You might have noticed that. You might be spamming a little bit there. So just be a little careful with what you put in the chat there. Nothing wrong, but just be aware. I hope that's okay. Where was I? Sorry, got sidetracked for a second there. Those are some mighty fine looking points. Yeah, I think they look okay. I was saying though, so I have a lot of in these beginner. What programming language is it? Oh, that's a great question. So this language that I'm using is called Clojure. Here, Clojure.org. Clojure. So it's spelt a little differently than you might assume. It's a Lisp language. In general, it's Lisps are a certain type of programming language that it's a whole family that has certain characteristics about it. I'm not going to go into detail about it right now, but if you're interested at all, you can search some of those. So Lisp, Scheme, Clojure, and have a read about it if you're interested, of course. Yeah, so Clojure is the language I'm using. That's all. If you're familiar with Java at all, Clojure runs on the Java virtual machine. So it can use a lot of the library. Well, it can use any library that's written in Java. You can pull all the functionality from Java into Clojure, basically, which makes Clojure quite a powerful language because Java is such a it's such a what am I trying to say? The libraries in Java are there's a lot of them, and the industry is built up and used Java very well over time. So there's a ton of support for Java, a ton of power in Java, well established. There you go. That's the right way. Because I'm not going to say that everything in Java is well built. That's not correct. But well established is exactly what I was grasping for. Thank you, Mike. Oh, okay. I was saying earlier, here I'm littering in a lot of my code things like map floats and add z and drop z, And those are just because I need to be more careful about how I design certain functions. Excuse me. In general, I want to be able to work with 2D and 3D lists of points, but certain functions need them to be in the form of 3D, and I haven't built that coercion into those functions. So I'm forced to add and drop Z, or Z as I normally say. I have to add and drop Z a lot, and that's really not smart, nor do I think it's smart to have to coerce floats all the time. So I want to approach this in a more efficient or a more abstract way, so that users of the functions don't always have to do all kinds of weird stuff like that within reason, right? Like if you pass a list of strings into something that expects a list of point data, it will fail, and that makes sense. But if you pass a list of points that are in that are rational, like they're fractional, it would make sense that you don't have to explicitly coerce it to float yourself. At least that's, I don't know, the ergonomics of that feels nicer. So I realize that as I write my own code here, right? Like this here, drop Z comes up a lot, and I don't totally like that. But does this work? Let's give it a try. I just defined it like 3 times in a row. There we go. Coerce to float, no problem. And let's see if that actually just lets me draw the line normally. I think it will. There we go. Okay. So here is an interesting kind of problem. Well, not a problem, right? It's not 100% clear, given a line that I drew by hand, by what reasons can I judge it to be a straight line? And is this the most appropriate straight line to replace it with? I have a starting point, like for the first quarter of the length of this line, that line fits really quite nicely, but then it diverges here and it's not on there at all. But if I drew this by hand, did I intend it to have that curve, or was that just because I'm bad at drawing straight lines? You know, I don't know exactly how I want to approach this. But before I get all philosophical about it, what I do want to do is draw a different line and run the same algorithm and see if it actually gets me nice points on a different line at a different orientation. So I'm going to get my iPad for just a second, and I'm going to I'm just going to run this on a new drawing. Where was it? Here we go. Time to be another line artist. And of course, after all of those things are considered, I will have to consider how can I disambiguate. If I draw a continuous ink thing that has a corner on it, I need a way to detect corners, detect points on corners, and start doing all kinds of stuff like that. So there's a lot of interesting work to do. Should be fun. Let me just draw something here. Okay, so here is the worst way to screen share an iPad. Here's the line that I have drawn before. I'm basically just going to draw something the other direction. Very simple. Nothing crazy at all. I think that's good. Okay. PNG. Let's run this little script. Okay, and now when I rerun this, it should be a new line. Let's see if it works. Okay. Ah, well, it didn't. That's interesting. I'm actually a little surprised as to, I'm surprised by that, to be totally honest. Let me think though. Okay, there's a problem. When it was, let me confirm if my brain is thinking about this correctly. I'm going to draw something that is the same orientation but much steeper, and run it again, because I think I made a silly mistake about my assumptions there. You're laughing at my misfortune, Alex? It's important to test things, right? Because obviously it's not working, so you know, good to know, better to know. Yeah. I wasn't thinking about the different cases for sorting. So you're totally right, Mike. It does in fact make sense. So this will only work with lines in this direction. It also clearly isn't working for like I'm not great at drawing straight lines, as we can clearly see. So yeah, so it's I was just being silly. I need to disambiguate, right? Like I need to know which pair up to do. So this is silly. I was not thinking about it. Okay, so what's the right thing to do? I'm running out of time. I'm going to probably get going in about 15 minutes, so I can just kind of brainstorm and think about it a bit. I probably won't be able to really implement all that much. But that's okay. You know, failure is still learning. Failure is very important. It's just not a big brain day for me, as is very clear. But yeah, Mike, you're totally right. It makes perfect sense. I should have obviously seen this beforehand. Seems as though this problem should instead break the line into a bunch of little lines that are saved, like remove the curve of the line by making it a bunch of smaller subsections. Yeah, so I'm trying to be... So your point is well understood. I'm going to draw a new shape and kind of explain what I would hope this leads to in some ideal world. Give me just a second to draw something out here. It'll still be really simple drawing, but it'll be a good illustration of what I am kind of hoping for, which I may have already explained. I mean, you may already know what I'm going to say, but I'm going to say it anyway. Sir, you can do it. Thanks for the encouragement there, Alex. I appreciate it. I know there's a solution out there, right? It's just a matter of figuring it out, and that's the fun of programming sometimes. Oh, a Rembrandt level drawing? Oh boy, the pressure is on. You know, I have some very artistic cousins, and one of my sisters went to school for a fine arts thing, and she does this amazing sort of abstract painting and things like that. I say amazing. I will admit I'm probably a little biased, but she's a pretty good artist. I do line sketches and stuff like that. I wouldn't say I'm actually horrible, but Rembrandt, I must apologize, is not happening today. I'll just temper your expectations for you up front there. I'll add a little something. Better than me, kids laugh at the stick figures. Stick figures, stick figures make the world go round, I swear. You don't need to be good at drawing to convey useful information with stick drawings. Oof. Alright, now I'm just wasting time. But it's fun. Okay, here, I'll send this now. This is a ridiculous drawing. Okay. Oh, it's a horrible, hideous mess. I actually didn't expect to see this clipping problem here. So if you ignore the weird triangles, I actually know how to fix that. I just haven't fixed it. Oh, how embarrassing. The actual drawing here, let me just so you're clear, that those clipping problems don't exist on this here. That's what I drew. Oh boy. Ridiculous. Right. So so if we ignore these erroneous endpoints here and the clipping problems, this drawing here, right? This cube is in some sense we interpret this as a box, right? And a box is three-dimensional. Even though I only ever drew lines in 2D, right? I intend to convey that it's three-dimensional. So the line discernment stuff that I'm trying to hack on now, what I would love is it to be able to, at the very least, discover this here as a single point, right? This is a vertex because there are clearly what we humans would describe as straight lines, even though it's not straight because I'm jittering when I draw. This point is three straight lines converging. So is this, and so is this. So I'm not necessarily trying to make functions that achieve line overlap accuracy, but I am interested in achieving a best guess fit of the minimal set of vertices and straight lines that will convey the 3D approximation of the shape you've drawn. Or 2D would even be useful, because let me draw something a little more practical. It would be very useful to be able to I'll give a story about where I could see something being actually really useful. I used to work at a greenhouse manufacturer, and a lot of that is aluminum extrusion, and we can design aluminum extrusions to be rather complex. But when you're just kind of hacking away at a drawing, right? You would talk with your peers, and it's way quicker often to just grab a pen and paper and draw out a profile shape. And then to manually have to put it into the CAD program is totally possible, but can be, it's not as fun, right? So imagine a scenario where I'm talking with another engineer, and we're like, oh, okay, so we want this profile to have a hook and a little pocket here to grab a shape. So I just will explain it to to the engineer as I'm drawing this profile. There's the hook, and then the pocket actually comes out like this. Oops. And I'll show the drawing in just a second, of course. And then you need a little lip like this and a thin piece at the end. Okay. So I've drawn some wacky looking profile, which I will share to the screen in just a moment. It'll probably bug out again, but I'll fix that in a moment. One second. Okay. Right, let's run it again. Oh, no bugs. Okay, so imagine this is a rough design for an aluminum profile, right? And imagine that this little heuristic engine that I'm trying to build correctly draws all of the corner points, point here, here, and various other spots, endpoint here, blah, 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 connects them all with straight lines, and then eventually does this other more complex discernment, which can find arcs and Bezier curves. So in a situation like this, I don't necessarily, this vertical line here, I don't really, if I want to put this into a CAD program, I don't need it to have a point at the top and then a point in 2 millimeters and then another point, another point, another point, another point. When I put it into my CAD program, I would select those all and delete those points anyway. What I would rather have is a good estimation of a vertex here and one vertex here, right? And have it be a straight line, because that is more closely related to what I, as the designer, intended when I drew this sketch out on the paper, in a way that a human would kind of understand it when they looked at it, that this is more likely to be a straight line than it is to be a nearly straight line with a bunch of smaller segments. So that would be the ideal approach. It's probably pretty difficult, but the straight line thing that I'm working on is a little more closely related to this kind of problem than a perfect match to the shape itself. I'm not sure if that makes complete sense. I hope it makes a little bit of sense. Excuse me. I have to get going soon, but I wonder if there's anything quick I can do yet before I leave. Gotta think about it. Yeah, I got what you're going for. Cool. Alright, this is a weird drawing, so let me do another straight line here for a minute. Just get back to the basics and maybe clean up this little hacky section for a minute, and then I can work on it off stream later. Clear? Okay. I'm also gonna, let's see here. Oop. Okay, that's a very straight line. I used a ruler. And I think, I do feel like maybe this ends up just being a silly gimmick. It'd be really fun to walk into a manufacturing place. I'm trying to talk about the library I'm building, and I take a picture of a back of the napkin drawing and then have that as part of the CAD file that gets shown on my phone or something like that. I think that'd be crazy. It'd be so fun. It'd be hilarious. I don't want to get ahead of myself though. Take things kind of one step at a time here. I think that should work. There we go. Okay, so those points are obviously not helpful. They're going to get me they're going to get me close to the midpoint, but not the line itself. So if I actually just do this, let me get this out of the way. I'm trying to think of a way that I could disambiguate these scenarios so that they're correct, and I'm struggling a little bit, to be honest. Right, so to get this to work for this side of things only, this is the last thing I'm going to do, then I should get going. But just as something to confirm, something to do to kill just a minute or two. First X points, reverse that, and then this one will be not reverse of this. Is that right? Oops. I messed. So this point's right. I messed this one up. That's my bad. Unless, no, I did mess it up. Where am I at here? Going crazy with all these functions. Gotta organize it. Okay. Here we are. Here. So the first point, what on earth did I do? Okay, let's fix this. Shouldn't this work? Maximum X, minimum Y, minimum X, maximum Y. This should work, I thought. Losing my mind right now. Well, that's gonna have to be okay for the time being because I'm getting short on time. Right, man, gotta run. Getting darker earlier. Gonna try get out while I have a bit of sunlight. Plan on streaming on Thursday? Yeah, Mike. Thanks for tuning in, and have fun on your on a run or whatever you're going to do. Thanks for tuning in. Yes, I will be streaming on Thursday. I will not be streaming Friday. So if you want to catch me, try to catch me on Thursday if you can. I would appreciate it, but no pressure on your end. You know the drill at this point. Yeah, I'll be back on Thursday though. Good luck with the rest of your day and the rest of your week. See you Thursday. Yeah, cheers to you too. Have a good one. Have a good one. I don't know why this is happening. All right. It's almost going to be time for me to skedaddle. So just got to think about what to do with this bonkers stuff. Okay. Did I typo something maybe? I might have typoed this is wrong. This doesn't make any sense, but let's just do it and see what happens. Just for kicks. Shoopadoo. Yeah, that's wrong, of course. Right. So, what do I do? Because I'm getting a little lazy at the end of my at the end of the day here, unfortunately. So I don't want to actually think too hard about what's going wrong. Unfortunately, that doesn't actually help solve problems. So let me have a look at this instead. If I just comment this out. Let's go back to a simple approach where I just do first of x points, and then here I do first of reverse of x points, so I get the last. Okay, if I return, that's a mistake there. If I return that, let's give that a try and see what happens on this. The points will be a little less accurate overall, but it might be reasonably close. So let's do this. Okay, there we go. It's not bad. Now let me see the difference now. If I do the y points, I should see a different but similar result. Basically, it'll be like it'll just tip a little bit around, like kind of pivot ever so slightly around the midpoint of this, more or less. So let's see if that is true. Yeah, that's pretty much true. So, so what's the right approach here? How should I get the result I need? How should I combine those two lines as a sort of average of the lines instead? I'm kind of thinking like I could do a for loop for all points, so I get all permutations of combos, then sort those combos by the minimum distance between the pairs, and then just get the two minimums, and that should be the correctly paired points. I'll try that quickly. It seems very brute force, but it's the first thing that came to mind, so I'll just try it for fun more than anything. So all of the points that matter, I'll do this way. I'll do points. It's just 4 points, so what's the is it 4 squared? It's 16 combinations, so it's a short brute force anyway, but it's kind of cheesy, but I'll go with it. The order won't matter either, so I'll just do this. First first x points, first y points. And then first reverse this, copy this, paste that right there, and I'll just do that. Okay, so those are all the points. Let me see that the 4 is working let's see if I have this correct. For A is, let's do range 4, B range 4, A, B. Yeah, okay. Good. That works the way I want it to. So that creates just a set of pairs, right? Then I think that I can work with that. Okay, so points and then pairs is just, I wonder if there's a smarter way to pair them off, but I'll just do it as a for loop. It's not a problem. For A, B, oh sorry, for A range, no, for A points, B points. I wonder, there must be a more concise approach for that, but this is the first thing that comes to mind, and that's okay with me. For A, B, points, points, you just do A, B like this. Okay, so that's the pairs now. And then here, I should be able to just do, let me see here. If I do f/distance, that's 2, yeah, okay. I should be able to sort by, take 2, sort by f/distance. I might have to do apply f/distance pairs. Okay, let's see if this will work. It might. Let's do idealize endpoints 2D of a shape. Okay, it doesn't break, which is neat. And that's a point and a point. Okay, that might have worked. Let's try. Oops. Ooh, error. Okay, not a big deal, just not great. Let's just do into this just to confirm that that's not the issue. Let's try it. Okay. I'm gonna have to sort that one out after. It's about time to go now. It was close. let me try this for a second. If I comment all that stuff out and just do iPoints, does it return a value for me, or does it null out still? Okay, so there are, oops. Count the results. Let's not count that, that's silly. Oh, wait a second. Does this make any sense? Okay, something's not right. Okay, so I have to get going now. There will be work for me to do. But that's going to be it for the day. So, thanks anyone for tuning in live and chatting. I always enjoy that. If there's anyone who is watching this after the fact as a VOD or as a YouTube thing, please consider following or supporting this channel by sharing it to other people, anything like that. You can join my Patreon, you can send donations. If you don't want to do any of that stuff, just, like I said, follow, share, like, comment, subscribe, anything like that. Very helpful. I want to grow this. I need help in the department of sharing and stuff like that. So go right ahead if you are so inclined. Regardless of any of that, thanks for tuning in, and I hope that you have a good day. See you on Thursday. Yeah, Alex, thanks for tuning in. I really appreciate it. Yeah, I guess I'll see you on Thursday. Have a good one, okay? I'll be on my way out, and I'll be back on Thursday. Goodbye.